Hello again, and welcome to some more AP Calculus Free Response Practices. First one I'm doing today is 2010 AP number 3. So this would have been a calculator OK question back in the day, because the figure above shows an above ground swimming pool in the shape of a cylinder with a radius of 12 feet and a height of 4 feet. The pool contains 1,000 cubic feet of water at time t equals 0. Between the time interval from 0 to 12 hours, water is pumped into the pool at a rate of 12, or P to the P of t cubic feet per hour. The table above gives values of P of t. During the same time interval, water is leaking from the pool at a rate of R of t per hour. And R of t is given by this equation. They also do give you the volume of a cylinder. Now, before I even look at the rest of this, this is one of those questions that I keep trying to tell you about. One of those rate questions where we have a rate in and a rate out. So if V is the volume of the pool, V prime here, the rate of change of the volume, is going to come from the rate that's being pumped in minus the rate that's leaking out. So I don't know if that's going to help us at all later or not, but just keep in mind that that's the rate of change of the volume, the in minus the out. Okay, so part A says use a midpoint Riemann sum with 3 subintervals of equal length to approximate the total amount of water that's pumped into the pool during the time from 0 to 12. Show the computations that lead to your answer. Okay, so if I want the total amount that is pumped in, well, that's just going to equal the integral between 0 and 12 of the rate that it's being pumped in. And this hopefully at this point is starting to seem familiar to you. When they ask me for a quantity that I have a rate for, this is essentially the derivative of the amount being pumped in. I take the integral of it. So the reason they want us to use a midpoint Riemann sum is because the only information we have for P of t is a table. And they want 3 subintervals of equal length. So between 0 and 12, if I'm going to split that up into 3 subintervals, how big are they going to be? 4. So think of a box between 0 and 4, a box between 4 and 8, and a box between 8 and 12. I'm using the midpoint sum. So remember, I'm picturing these as like big boxes that I'm finding the areas of, and they're all length times height, length times height. Okay, so we're going to have all the lengths are 4, and the height is going to come from the midpoint. So there's the midpoint, there's the midpoint, there's the midpoint. So that first box is going to be 4 by 46. Plus that second one is going to be 4 by 57. And that last one is going to be 4 by 62. And that's what can estimate that integral, because remember, Riemann sums are what we use to estimate integrals, because integrals just mean area under the curve. So I type this all into my calculator. I get an estimate of 660. Okay, so it didn't say that I needed to put units, but if I wanted to, we're in cubic feet, so it'd be feet cubed. So that's an estimate of the amount of water that's pumped in. Part B says calculate the total amount of water that leaked out of the pool between 0 and 12. So this is kind of the same idea. If I want the total amount that's leaked out, I would just do the integral from 0 to 12 of the leak out equation, which I believe was R of t, dt. Since I have my calculator, that's pretty easy to do. I just have to do math 9 from 0 to 12. Let's see what R of t was. It's right there, 25 e raised to the negative 0.05x dx. So the amount that leaked out is going to be 225.594 cubic feet. So A and B are essentially the same question, just different representations of the formula. Okay. Part C, use the results from A and B to approximate the volume of the water of the pool at time t equals 12 hours. Round your answer to the nearest cubic foot. Okay, so let's take a minute to think about what's happening. We're starting at time 0 with 1,000 cubic feet. Okay, so at time 0, I have 1,000 cubic feet. 660 was pumped in. I'm going to add 660. This 225 number leaked out, so I'm going to subtract that number. That should give me my answer. It's that easy. 1,000 plus the amount pumped in minus the amount that leaked out. So I've got 1434.406 cubic feet. All right, so this has been a relatively easy question so far, which means part D is probably going to be a doozy. D says find the rate. Oh, wait. This is one of those tricky rounding. I almost missed a point here. Round your answer to the nearest cubic foot. So this should actually be 1434 cubic feet. Normally we do 3 decimal places, but if they tell us to round to something else, we've got to do that. Okay, part D. Find the rate at which the volume of water in the pool is increasing at t equals 8. How fast is the water level of the pool rising at t equals 8? Indicate units of measure in both answers. Okay, find the rate at which the volume is increasing. Well, there's that equation. V prime is the rate of change of the volume. I just got to do P of t minus R of t at t equals 8. Okay, so that part seems deceivingly easy. So volume prime is equal to P of t minus R of t. So volume prime at 8 is going to be P of 8, which is 60, minus R of 8, which I'd have to plug in to that equation. So 25e raised to the negative 0.05 times 8. 16.758, blah, blah, blah. So subtract those two, 60 minus that, 43.242, just say to round anything, just indicate units of measure. So 43.242, and if it's a rate of change of the volume was in cubic feet per, what's time in? Hours. So cubic feet per hours. Okay, so let's take a minute and figure out why I knew to do that. So I wanted the rate at which the volume of the water was increasing. That's why I said this to begin with. The volume's rate, the volume is changing. The rate of change of the volume is the rate that is being pumped in minus the rate that is being pumped out. So knowing that means I just had to plug into those equations. Now there is another part. How fast is the water level of the pool rising at t equals 8? How fast is this water level rising? Well, at any given time, we'll call this water level h. This radius is constant. That's always 12 because it's a cylinder. So this is a related rates question. For the second part of this, we want dh dt. And when do we want it? Now, when t equals 8. Okay, so we've got volume of the water. We don't really have a volume equation. We have the rate that it's changing, but we don't have an equation for the volume. That's why they tell you the volume of a cylinder is pi r squared h. So volume is pi r squared h. And remember, with related rates, if there's anything that's constant, I'm allowed to plug it in. In the case of a cylinder, the radius is constant. So I can plug in volume equals pi times the radius, which is 12 squared h. So volume is 144 pi h. Now, if I want dh dt, that means I have to take the derivative of this equation with respect to t. So dv dt would be equal to, what's the derivative of 144 pi h? Think of this as just a constant. So if this was like 5h, the derivative would just be 5. So this is just going to be 144 pi times dh dt. Now I want to find this. What's dv dt? Well, that's changing, but we know that's why they asked you this part. It was almost a hint. At t equals 8, which is when we want it, the rate of change of the volume, we wrote it as v prime over here, but that's dv dt. V prime of t is the same as dv dt, is 43.242 equals 144 pi times dh dt. So I just have to divide, and I got my answer. Divide by 144 pi. And I can do alpha y equals, I should do that, and do 43.242 divided by 144 pi. And that's going to be 0.096. And they want units. So if I'm talking about the height, well, since this is in cubic feet, this height's going to be in feet, and the time is hours, so it's feet per hour. Okay, so I would say this isn't that bad of a problem. The last part might have been confusing if you hadn't seen it, but hopefully it makes sense from me going through it. Okay, number 2. Okay, here's one from 2009. Let f be a function that's twice differentiable. What's that mean? It means you're able to take the derivative twice. Table above gives values for f at selected points between 2 and 13. Estimate f prime of 4. Okay, so if I want to estimate f prime of 4, and I have f, how is f prime related to f? Well, f prime of 4 means the slope at x equals 4. And I know you've all seen ones like this before if you've been doing the homework. So the slope at 4, the best I can do is take the slope between 3 and 5. So I can do change in y over change in x, and I'm going to get -2 minus 4 over 5 minus 3, which is -6 over 2, which is -3. That's it. So if you have a table and they want a derivative, just take a slope around that point. Okay, part B. Evaluate the integral from 2 to 13 of 3 minus 5 f prime of x dx. Show the work that leads to your answer. Okay, a little weird maybe. Integral from 2 to 13 of 3 minus 5 f prime of x dx. Well, if this was just a normal equation, what would you do? Well, if it was a normal equation, you would take the antiderivative, plug in 13, plug in 2. That's kind of what I want to do. So what's the antiderivative of 3? 3x. What's the antiderivative of 5f prime? Minus 5f of x. 5 is just a constant, so we can move that out front if we needed to. That's why it stays here. And the antiderivative of f prime is f. Looks weird, but it's not that hard. And I'm evaluating from 2 to 13. You just have to know the rules of calculus and apply it to a weird-looking equation. So now this is going to be, if I plug in 13, 3 times 13 minus 5f of 13 minus, plug in 2, 3 times 2 minus 5f of 2. Okay, so this is 39 minus 5. Do I know f of 13? I sure do. It's 6. So minus 5 times 6 minus 6 minus 5 times, what's f of 2? 1. So 39 minus 30, this is just 9 minus 1, it's 8. So again, not hard, you just have to know the trick. And think about that. If you have something that looks weird, apply the calculus rule that you know. You know how to take the antiderivative. The only weird part of this was that the antiderivative of f prime is f. Okay, part C. Use a left Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13 of f of x dx. Okay, well, we've done this. Integral from 2 to 13 of f of x dx. It says to use a left Riemann sum with subintervals indicated by the data in the table. So that means we're going to use all the subintervals we can. So we're going to go from 2 to 3, 3 to 5, 5 to 8, 8 to 13. So these are all boxes that I'm taking areas of. And since it's a left-hand Riemann sum, I'm using the left endpoint. So we're going to take the base times the height of all of these, and the height's going to be whatever the left endpoint value is, which is going to be these values. Okay, so the first one has a base of 1 and a height of 1 because the left endpoint has a value of 1. So it's 1 times 1 plus the second one has a base of 2 times a height of 4 because that's the left endpoint. 2 times 4 plus this one would be a base of 3 times a height of negative 2. Keep the negative in there. Okay, and then the last one would be a base of 5 times a height of 3. All right, so this is just 1 plus 8 minus 6 plus 15. What's that? 9 minus 6 is 3. Looks like 18 to me. Okay, again, not terrible. D is always the weird one. Not always, but a lot of times. Suppose f prime of 5 equals 3. F double prime is negative for all x in the closed interval from 5 to 8. Use the line tangent to the graph of f at x equals 5 to show that f of 7 is less than or equal to 4. And use the secant line to the graph of 5 between 5 and 8 to show that f of 7 is greater than or equal to 4/3. Okay, this seems weird. And when I read this, I'd be confused too. So zero in on what you do know. I see use the line tangent to the curve at x equals 5. Can you find a tangent line at x equals 5? Sure. For tangent line, you all know to do goal y minus y1 equals m times x minus x1. Okay, what point do we have? Well, I think it said x equals 5, right? So when x equals 5, the y value is negative 2. So the point's 5, negative 2. How would I find the slope? That would be f prime of 5. Did they tell me that? Yup, it's 3. So y plus 2 equals 3 times x minus 5. All right, so I've at least got a tangent line. We want to show that f of 7 is less than or equal to 4. So it sounds like I want to use the tangent line, plug in 7 for x. What do I get if I plug in 7? Y plus 2 equals 3 times 7 minus 5. Y plus 2 equals 3 times 2. So that's 6. So y equals 4. Okay, well that's probably good news because I have this f of 7 being less than or equal to 4, so 4 is involved. But how would I use the tangent line to show that it's less than or equal to 4? Well, the only piece of information I haven't used yet is that f double prime is negative between 5 and 8. If f double prime is negative, what's that telling you about f? F is concave down. So think about what that means. Here's concave down. Let's say this was 5. There's my tangent line. So if I plug in 7 and I get 4, the fact that it's concave down means that the actual point has to be below 4. So since f is concave down, tangent line is an overestimate. Therefore, f of 7 must be less than or equal to 4. Because if it's an overestimate, the tangent line's up here, and that gave me 4. Since it's concave down, this graph has to bend downward, so it has to be below 4. Okay, last part. Use the secant line between 5 and 8 to show that f of 7 is greater than or equal to 4/3. Do you remember what secant line means? Secant line is just the regular slope over the entire interval. So let's say I'm looking at the secant line on something that's concave down. So secant would equal change in y over change in x. Now they're asking me over 5 to 8, so that's my change in x, 8 minus 5. Let's use the table. F of 8 is 3, f of 5 is negative 2. So 3 minus negative 2, which gives me a 5 on top and a 3 on the bottom. What do you know? So I got 5/3. I wanted 4/3. Okay, well, if I use the secant line, that's just the slope of the secant line. The actual secant line, I could use either point. So let's use 5, negative 2. The equation of that line would be y plus 2 equals 5/3 times x minus 5. And again, we're talking about at x equals 7. Y plus 2 equals 5/3 times 7 minus 5. Y plus 2 equals 5/3 times 2. So that's y plus 2 equals 10/3. If I subtract 2 from 10/3, that's like subtracting 6/3. What do you know? Y equals 4/3. And just from my picture, you can see if I take a secant line on something that's concave down, it's an underestimate. So I could say since f is concave down, secant line is underestimate. Therefore, f of 7 must be greater than or equal to 4/3. Okay, so again, part D was a little bit weirder. You probably could get some points out of it. It might be hard to know how to do all of this analyzing, but we used all the pieces of information that they gave us to get that result. Obviously, your goal is always to get as many points as you can, but remember, it's okay if you only get 4 or 5 out of the 9 points. Keep that in mind when you see a weird question like that. All right, one more, and then we're done. One of these again. Let f be a function defined between -5 and 5 with f of 1 equals 3. The graph of f prime, the derivative of f, consists of 2 semicircles and 2 line segments shown above. Immediately, I'm going to write what I do on all of these. F prime equals the graph, which means what does f double prime equal? Be the slope of the graph. And what would f equal? I wanted to take the integral and go backwards. Integral means the area. Okay, keep that in mind. Part A, between -5 and 5, find all values of x for which f has a relative max and justify. Okay, if I want a relative max of f, if I had an equation for f, what would I do? I would take the derivative and set it equal to 0, or it does not exist. Don't forget that. Well, if I want to know where the derivative equals 0 or does not exist, I just have to look at where the graph equals 0. Now, the graph exists everywhere. There's no asymptotes or holes or anything like that. But it equals 0 at x equals -3, x equals 1, x equals 4. I'm not including -5 because that's an endpoint that's not included. Then, to find maximums, we would do our number line test. So plot -3, 1, and 4. For -3, the graph is positive. Between -3 and 1, it's negative. Between 1 and 4, it's positive. And after 4, it's negative. So we want local maximum. So increasing to decreasing, right there's a maximum. Increasing to decreasing, right there's a maximum. So we could say max at x equals -3 and x equals 4 because f prime changes from positive to negative. Don't forget to justify if it asks you to. Okay, that was part A. Part B, between -5 and 5, find all values of x for which the graph has a point of inflection. Okay, so again, I'm going to say, how would you normally find a point of inflection for f? You would set the second derivative equal to 0 or does not exist. So I would need to know, where does the slope equal 0 or not exist? Well, that looks like at -4, -1. And in places where the slope doesn't exist here, vertical tangent, here, corner, or here, corner. So we have -4, -3, -1, 1, and 2. Those all need to go on a number line. -4, -3, -1, 1, and 2. Now most people will get -4 and -1. Don't forget slope not existing. Corners, cusps, vertical tangents. Okay, we're looking at the slopes. So the slope before -4 is positive, and it's negative after. Positive, negative. After -3, slope is still negative. After -1, slope becomes positive again. And after 1, slope is still positive. And finally, after 2, slope is negative. So which ones are actually inflection points? So remember, the signs have to change. So -4 and -1 and 2. So x equals -4, x equals -1, x equals 2, because f double prime changes signs there. Remember, saying it changes signs is enough. You got to specify what it is. All right, part C. Find all intervals for which the graph of f is concave up and also has a positive slope. So concave up would mean what? You need f double prime to be positive. Concave, positive slope, what needs to be true there? F prime needs to be positive. So I've already got these number lines from these last two. I just need positive f prime and positive f double primes. Remember your interval. You're on -5 to 5, and we can include the endpoints because this is the overall interval that the function's allowed to be. So they're both positive starting from -5. This one up until -3, this one up until -4. If you need them both to be true at the same time, you can't go past -4. This is positive at 1. This is also positive at 1, so I can say from 1. Here it's all the way 1 to 4. Here's just 1 to 2. So in order for them both to be positive, we can only say 1 to 2. And my reasoning would be because both f prime and f double prime are positive there. because it said explain your reasoning. Okay, finally, part D. Find the absolute minimum of f of x between -5 and 5. Okay, we've gone over this before. Where can absolute mins occur? They can occur at critical points or endpoints. So the only critical point where f prime equals 0 that was a min was 1, because -3 and 4 were maxes. So if I'm looking for an absolute min, I don't need to worry about -3 and 4 because they're not mins, but 1 is potential. So I got to check that. So we're going to make a table. Now check 1 and the endpoints, which were -5 and 5. Now usually they give you some information. Did they do that here? They said that f of 1 was 3. That's good news. So that one I know. All right, so if I want to find f of -5, this is where fundamental theorem of calculus comes in. I would take the integral from -5 to 1, -5 because I want to find it, 1 because I know it, of f prime of x, and that's going to equal f of 1 minus f of -5. We know f of 1 is 3, so I can solve for f of -5 if I can figure out this integral. And if I'm taking the integral of a function that I have a graph for, I need to look at the area. So the area between -1 and, or -5 and 1. So that area minus that area. So both of these are semicircles, and I told you that. So I can assume this is 1/2 pi r squared. And the radius of this semicircle is just 1. So this would just be 1/2 pi. The radius of this semicircle is 2. So this would be 1/2 pi times 2 squared. And 1/2 times 4 is 2. So this would be 2 pi. So I have 1/2 pi minus 2 pi. 1/2 pi minus 2 pi. What is that? Well, this would just be 4 pi over 2, so that's -3 pi over 2. Equals 3 minus f of -5. And if I solve for f of -5, I'm going to move this over here. F of -5 equals 3 plus 3 pi over 2. Now, if you have a calculator, you can use that to compare, but if I'm looking for the absolute minimum, is that going to be smaller than 3? Obviously not, because I'm adding something to it. So it's not this one. Just got to do this last one now. So now I want to find 5. So again, use something you know to something you want to find. Of f prime of x would be equal to f of 5 minus f of 1. I don't know f of 5. I know f of 1 is 3. Here I need the area between 1 and 5. So the area between 1 and 5 would be this area, counted positive, minus this area, counted negative. They're both triangles. So this would be 1/2. The base is 1, 2, 3, times the height is 2. So that's just going to equal 3. What's this? 1/2. The base is 1. The height's -1. So that's just -1/2. So 3 minus 1/2. This is like 6 halves minus 1/2. So that's 5 halves. Add the 3 to it, and I'm going to have that f of 5 is 3 plus 5 halves. Now I can figure out what that is, but again, I don't really care because it's 3 plus again. It's more than 3. So this tells me that, what does I want to find? The absolute minimum value. Absolute min value is 3 occurs at x equals 1, but they didn't ask that. And your reasoning would be because it's the min value when f is evaluated at critical points and endpoints. All right, that's all I got. So hopefully those seemed a little bit more manageable to you. Some of them had weird parts, but again, you're starting to see the same type of things over and over. Thanks for watching.